Good evening. Today's quote is by Socrates. The only true wisdom is in knowing you know nothing. The only true wisdom is in knowing you know nothing. Today's word is aberration. I think you use this in physics also. The meaning is the act of departing from the right normal or usual course, the act of deviating from the ordinary, usual or normal type, deviation from truth or moral rectitude. In optics, that is in physics, any disturbance of the rays of a pencil of light such that they can no longer be brought to a sharp focus or form a clear image. Today we are going to start an interesting and an important topic, complex numbers. Actually, the word complex is there in the name of the topic, but it is not at all complex, it is simple one. Consider the equation, consider the equation x square plus 9 equal to 0. This is the same as x square equal to minus 9. Solving this equation means finding a number whose square is minus 9. Clearly, x cannot be a real number. Why? Because the square of a real number cannot be negative. That is, we cannot find a real number whose square is minus 9. Similarly, the equations of the type say x square plus 1 equal to 0, x square plus 11 equal to 0, etc. They cannot have their roots as real numbers. In order to overcome this difficulty, we have to introduce a new type of numbers whose square is negative. Now, next part is important. We haven't done this before. Root of minus 1. Remember, root of minus 1 is a non-real number. It is denoted by the symbol small I, not capital I, small I, and it is called as an imaginary unit. It is called as an imaginary unit. Okay, actually this stands for Greek alphabet iota, IOTA. I think this is ninth Greek alphabet. In the next lecture we will discuss about Greek alphabets also, because you need not know all the Greek alphabets, but few we will be using in maths and of course in physics also, right? So this is about an imaginary unit. Now, as I equal to root of minus 1, what will be I square? I square is nothing but minus 1. Is that clear? Good. Now we are in a position to define. First, again, I'll tell you the definition of imaginary number, and then we will define complex number. A number of the type, you have to listen to me, do not write. I'm going to upload a file in which you will find all these things. A number of the type ki, where k belongs to r. This is also a Greek alphabet. You have to read this as epsilon. K belongs to r. K is not equal to 0. Okay. And I equal to root of minus 1 is called an imaginary number. I repeat the definition. A number of the type ki, where k is a real number or non-zero real number and I equal to root of minus 1 is called an imaginary number. For example, 7i, pi I, okay, minus 1 upon 13i, root 11i, all these are imaginary numbers. Now, what are the properties regarding this? Properties regarding this imaginary number? You should know that I into 0 equal to 0 into I, which is nothing but 0. Okay. Now this is important. What is root of minus a square? Root of minus a square, where a is real number, is written as root of minus 1 into root of a square. Now what is root of a square? Plus minus a. And what is root of minus 1? I. So I write this as plus minus ai. I hope you are getting this. And third important property, you can say, suppose a and b are real numbers. Okay, and ai is nothing but bi, then a must be equal to b. This is quite logical. Okay, so this is about imaginary unit. One student is saying, sir, please wait, I haven't just finished writing. See, you're not supposed to write this, I already told you. Now complex numbers, I think I had given which equation? X square plus 4x it was, I'm sorry, not 8x. X square plus 4x plus 8 equal to 0. Let us solve this equation. Now I write this as x square plus 4x plus 4 plus 4 equal to 0. Is this correct? Yes. I have written 8 as 4 plus 4. Now for the first three terms, can I write x plus 2 bracket square? Yes, I can. Equal to minus 4. Right? Now, next step is important. After this, I will say x plus 2 equal to, or before that, let me write 4i square. Is this correct? Yes, it is. Why? Because minus 4 is 4 into minus 1. But we have decided that I is root of minus 1. So what is minus 1? I square. So I get the equation x plus 2 square equal to 4i square. So what is x plus 2? It is plus minus how many i's? 2 i's. X plus 2 equal to plus minus 2i. That is x equal to minus 2 plus minus 2i. So the two values of x are, the first is minus 2 plus 2i and the second is minus 2 minus 2i. Right? So this equation has two solutions. Clearly, they are not real numbers. Is that clear? Such numbers are called as complex numbers. So if I ask you to define what is complex number, what will you say? A number of the type a plus ib, a number of the type a plus ib or a plus bi, same thing, ib is same as bi. A number of the type a plus ib or a plus bi where a and b are real numbers. This is very important. A and b are real numbers and I an imaginary unit, that is I equal to root of minus 1, is called as complex number and it is usually denoted by z. So z equal to a plus ib is a complex number. Examples, many examples can be given. In this case, minus 2 plus 2i, this is a complex number. Then 13 plus root 17i is again a complex number, right? Now, if a plus ib is a complex number, a is called as, listen to me, a is called as real part and b is called as imaginary part. See, b is an imaginary part, but it is a real number. Then why it is called as imaginary part? Because it is attached to an imaginary unit. So a is real part, b is an imaginary part, but both the parts are necessarily real numbers rather. Now, real part of complex number is denoted by real z or simply rz, that is real part of complex number. Okay, imaginary part can also be denoted by im, means imaginary part of complex number, or just I imaginary part of complex number Z. Okay. Now the set of complex numbers will be denoted by capital C. See, initially we considered basic set as set of natural numbers. Then 0 was added to that. So it was called as set of whole numbers. Then set of integers. Then set of rational numbers. Then set of irrational numbers. And the superset of all these, I'm sorry, is called as set of real numbers. Now I can say that set of real numbers is a subset of this set. So what is the universal set? The universal set is the set of complex numbers. I hope this is clear to you. Now a complex number whose imaginary part is 0 is purely real. For example, if I ask you, is z equal to 4 a complex number? Yes. Why? Because can I write 4 as 4 plus 0i? Yes, I can. So this is a complex number whose imaginary part is 0. So it is called as purely real number. So can I say that every real number can be considered as a complex number whose imaginary part is 0? Is that clear? And that is why the statement is justified that set of real numbers is a subset of set of complex number. A complex number whose real part is 0. A complex number whose real part is 0 is called a purely imaginary number. For example, I minus root 7i, all these are purely imaginary numbers. And the last part, a complex number whose both real and imaginary parts are 0 is called as zero complex number, because I can write 0 as what? 0 is nothing but 0 plus 0i, right? So this is a zero complex number. See, you may say, sir, this is overdose of theory part, but I can't help. We will discuss few more terms, then we will solve few sums, and then again remaining theory part. Okay. Now, algebra of complex numbers. See, this is not at all difficult, but you should know this. First, we discuss what is the title? Algebra of complex numbers. First, we discuss equality of two complex numbers. Two complex numbers, say Z1 equal to A plus IB, and say Z2 equal to, you can say A1 plus IB1, or you can say C plus ID. Two complex numbers, Z1 equal to A plus IB and Z2 equal to C plus ID, are said to be equal if and only if. Standard short form for if and only if is IFF. If and only if A is equal to C and B is equal to D. That is, real part equal to real part and imaginary part equal to imaginary part. I hope this is clear to you, right? So if I get 3 plus AI equal to B minus 1 upon 11i. Can you tell me the values of A and B? As two complex numbers are equal, real part must be the same as real part. So value of B must be 3. And what must be the value of A? A must be minus 1 upon 11. I hope this is clear to you. Okay. You should also remember one important thing, that the order relation, that is inequality, the order relation of complex number cannot be defined. Hence, there does not exist a smaller or greater complex numbers than the given complex number. This is worth repeating. The order relation, that is inequality of complex number, cannot be defined. Hence, there does not exist a smaller or greater complex number than the given complex number. Okay. Then the last concept before we start solving sums, that is conjugate of a complex number. Now, This word is important. I think you have heard this word, right? In case of certs, conjugate of a complex number. Now, I will not tell you the definition. I will give the complex number and I'll tell you its complex conjugate. The conjugate of complex number z is denoted by z bar. It is called as complex conjugate. Okay. Now, let me give you examples. Suppose it is 3 minus 4i, then second complex number is 11, then the third complex number is um, 10i plus 15, then minus root 2i. Okay, I will be giving three examples. The complex conjugate of 3 minus 4i is 3 plus 4i. The complex conjugate of 11 is 11. That of 10i plus 15 is 15 minus 10i. And that of minus root 2i is nothing but root 2i. Now, can you tell me how complex conjugate is to be obtained? Yes, what you say is absolutely right. See, do not remember that some students say that change the sign between two terms. No, because 10i plus 15. Have I written complex conjugate as 10i minus 15? No. So the working rule is simple. You have to change the sign of an imaginary part. Okay. So imaginary part is minus 4. It becomes plus 4 in the conjugate. What about 11? I can write 11 as 11 plus 0i. So write it as 11 minus 0i, but there is no need to write 11 minus 0i. So we say that the conjugate of 11 is 11 only. 10i plus 15, the imaginary part is 10, you have to change its sign, so it becomes minus 10. So minus 10i plus 15 means 15 minus 10i. What about this? Minus root 2i, it becomes plus root 2i. Or you may say 0 minus root 2i changes to 0 plus root 2i, that is root 2i. I hope this is clear to you. So how will you define conjugate of a complex number? These are particular examples, but when you write or explain the definition, you have to consider general case. Two complex numbers, a plus ib and a minus ib, where a and b are real numbers and I root of minus 1 are called complex conjugates of each other. A minus ib is the conjugate of a plus ib and a plus ib is the conjugate of a minus ib. I already told you that complex conjugate of say z equal to a plus ib is denoted by z bar, which is a minus ib. Now, what are the properties? Can you tell me the conjugate of conjugate? Yes, it is original complex number. See, this is z. What is z bar? A minus ib. What is complex conjugate of this? A plus ib. That is original. So conjugate of conjugate is original. If I say z equal to z bar, can you draw some conclusion? If I say z equal to z bar, can you draw some conclusion? In that case, b must be equal to 0. That is, if z is z bar, z is purely real number. I hope you are getting this. Okay. So this is about the conjugate of complex number. Actually, we have to discuss four more operations, but out of them, we will discuss addition, then subtraction and multiplication of complex numbers. So we begin with addition of complex numbers. See, addition is not at all difficult. before I tell you actual definition, uh, I will give one particular example because it can be understood easily. If I ask you to add 2 plus 3i to which complex number? Minus 4 plus 7i. What will you do? Yes, very good. You will add 2 to minus 4. That is, you will add real part to real part. What is addition of 2 and minus 4? Minus 2. Very good. And then you will add 3i to 7i. That is, you will add imaginary part 3 to imaginary part 7. So, what is the answer? 10i. Okay. So, how to add two or more complex numbers? By adding real part to real part and imaginary part to imaginary part. Now we have to define addition by considering general complex numbers also. So if z is a rather z1 is a plus ib and z2 is c plus id. So this is not at all difficult. Then what is z1 plus z2? It is, as I said, a plus c, real part to real part, and imaginary part. I'm sorry, I should write b here. B plus di, real part to real part and imaginary part to imaginary part. Clearly, z1 plus z2 is what? Z2 plus z1. Simple. I hope you are getting this. So this is about addition of complex number. Now, if I ask you to multiply a complex number by constant, suppose complex number z is 7 plus 3i, and if I ask you to find 4z, can you tell me the answer? Yes, to multiply a complex number z by 4 means to multiply both the parts, distributive law. 4 into 7 plus 3i, open the bracket to get 28 plus 12i. Yes, so this is called as scalar multiplication. One student is asking, sir, are such questions asked in the exam? No, you won't be asked to write a note on equality of complex number. You should know how complex numbers can be equal, or if they are equal, what happens. Okay. Then comes subtraction of complex numbers. Suppose Z1 is A plus IB and Z2 is another complex number C plus ID. Okay. Then how Z1 minus Z2 is defined? Z1 minus Z2 is subtraction of two complex numbers. Yes, what you say is absolutely right. A plus IB minus C plus ID. As I said, scalar multiplication means multiply this complex number by minus 1. So minus C minus D. Now real part goes with real part and imaginary part goes with imaginary part. So in short, you can say that how subtraction is performed. From real part subtract real part and from imaginary part subtract imaginary part. One student is saying, can you explain scalar multiplication? Yes, I will. See, logic is very simple. Suppose z is a complex number and we have to multiply it by any real number. This is particular example. Z is 7 plus 3i and I want to multiply it by scalar. Scalar means constant. I want to multiply it by 4. Will you say out of 4 use 2 for 7 and 2 for 3? That is, use 50% for real part and 50% for imaginary part. No. 4z means 4 into 7 plus 3i. Just open the bracket. So it is 28 plus 12i. That is, we multiply both real and imaginary parts by this scalar. Is that clear? Actually, even if we do not discuss this, then also you will be able to solve most of the sums. For example, scalar multiplication. If z is given to be 7 plus 3i, and if I ask you what will be minus z, you will directly say simple minus 7 minus 3i. So this is subtraction of complex numbers. Uh, I think we will be able to solve a few sums from exercise 1.1, and after that we will discuss two operations: multiplication of two complex numbers and division of two complex numbers. That is to divide one complex number by other non-zero complex number. Exercise 1.1, simplify. First sum, root of minus 16 plus 3 root of minus 25 plus root of minus 36 minus root of minus 625. You may be thinking that can I take this minus under the radical sign? No, that is absurd. Root of minus 16 is root 16 into root minus 1. Now here you may also ask, sir, why not to take plus minus 4? In such cases, by root we mean positive root. So this is 4. What is root of minus 1? I. So this is 4i plus 3 into how many i's? 5 i's plus 6 i's minus 25 i's. So this is 4 plus 15 plus 6, 25i less 25i equal to 0i. But while writing final answer, you have to say it is 0. Write down. I think I should give second for homework, or you may solve that here only. I'll give the answer. Those who have already finished the first part can do the second part. I've given the answer. Very good. If you have just finished solution of the first part, write 11i. Okay. Now, second question. Write the conjugates of the following complex numbers. I will make the table. First column headed by Z and the second column headed by Z bar. This is Z and this is Z bar. Okay. 3 plus I. Every time you have to say that to get the conjugate, we have to change the sign of imaginary part. Don't say middle sign, because 3 plus I, if it is written as I plus 3, conjugate will not be I minus 3. It will be what? Minus I plus 3. Right? So change the sign of an imaginary part. What is the complex conjugate of 3 plus I? It is 3 minus I. Second, now we have to solve all the sums. 3 minus I. What is the complex conjugate? 3 plus I. Third one, minus root 5. Okay. Minus root 7i. So it is minus root 5 plus root 7i. Okay. Now you have to be careful. Fourth one is what? Fourth one is minus root minus 5. I hope you won't say minus minus plus. That is absurd. How can you take this minus sign under radical sign? No. Basically, this is nothing but, see, I'm writing all the steps. Minus, what is root of minus 5? It is root 5 into root of minus 1. So it is minus root 5i. So it will be the complex conjugate. It will be root 5 into I. I hope you are getting this. I repeat, please do not say minus minus plus, that is absurd. Now fifth one, phi I. So it is nothing but minus phi I. Now complete remaining. Yes, these are the answers for 6, 7, 8. Just check the answers. Now third question rather. Find A and B if, first question, A plus 2B plus 2AI equal to 4 plus 6I. After this, we have to say on equating real and imaginary parts separately. Please do not write directly. You have to write this. Therefore, what is the real part? Real part is one which lacks I. So A plus 2B on left hand side, on right hand side, it is 4, equation 1. On left hand side, see many students write 2AI, that is wrong. 2AI is an imaginary number. When we say imaginary part, it has to be a real number. It is attached to I, imaginary unit. So on left hand side, it is 2A. On the right hand side, it is 6. If you write 2AI equal to 6I, you should not get full marks because you have written equating imaginary parts. Okay. If you say 2AI equal to 6I, that is not wrong. But when you say equate imaginary part, it is just 2A. So what is A from this? It is 3. Put in 1. Therefore, 3 plus 2B. So what is B from this? 2B is 1. So B equal to half. A good student is one who will write answer in this fashion. Answer A equal to 3 and B equal to half. Right up. Uh, Now we discuss last two important operations, multiplication and division. Now in the textbook they have taken general case, and actually that should be the case, but it can be understood easily if we consider particular values. This is z1. This is z1 first complex number 3 plus I. Second complex number z2 is minus 1 plus 4I. The product is denoted by z1 into z2. So it is 3 plus I, don't write, just listen to me, into minus 1 plus 4I. Distributive law, first we multiply by 3. So 3 into in bracket minus 1 plus 4I, okay, plus I into in bracket minus 1 plus 4I. Now open the bracket, 3 into minus 1 minus 3. 3 into 4I. We have just discussed how to multiply a complex number by scalar 3. So 3 into minus 1 plus 4I is minus 3 plus how many i's? 12 i's. Okay. Now same rule is there for multiplying minus 1 plus 4I by I. I into minus 1 minus I. Okay. I into 4I, 4II, that is 4I square. But we know that I square is minus 1. So in the next step, I will write minus 3 plus 12I minus I. Can I write minus 4 directly? In exam, you are supposed to write 4 into minus 1 because I square is minus 1. 4 into minus 1 is minus 4. Remember, any complex number is to be written in which form? a plus ib. So I can say this is minus 7 plus 11i. That's it. This is multiplication of complex numbers. Actually, I should have taken Z1 as A plus IB, Z2 C plus ID, open the bracket and so on. Okay. You will find that in the PDF file. I already, in fact, I will rather upload theory part. See, today I'm going to upload only one file. Okay. In that, you will find theory part, then sums for homework. Actually, there is one more exercise given, classwork sums, but we will not follow that. We will solve all sums from the textbook. So you have to use that PDF for two purposes. You will find theory part there, and secondly, homework sums. Okay. Now, what about properties of multiplication? See, I can say that, see, this is Z now. Z1 into Z2 is Z2 into Z1, right? That is multiplication. Usually 3 into 4 is 4 into 3. This is called as commutative law, like that. Uh, can you tell me what is Z bar? Now, this is an interesting question. Z into Z bar. Suppose I consider Z as A plus IB. Can you tell me what is Z bar? A minus IB. Take the product. See, this is first plus second into first minus second, square of the first, that is A square, minus square of the second. What is square of IB? I square B square. But note that I square is minus 1. So this is A square plus B square. So the conclusion which can be drawn is product of a complex number and its conjugate is purely real. See, every real number is a complex number, but this is purely real. This also gives us factors of a square plus b square. Note that a square plus b square has no real factors, but it has imaginary factors. A plus ib, a minus ib. Is that clear? Good. Now, can you tell me about SUM sum of Z and Z bar? Let us find that also. Z plus Z bar is simply 2A, because IB gets cancelled with minus IB when added. Now, 2A is also purely real. So I can draw the conclusion. That and product, sum and product of two conjugate complex numbers are always real. I repeat this statement. The sum and product of two conjugate complex numbers are always real. Okay. Then powers of I. Just listen to me, don't write. Powers of I. What is I? I is root of minus 1. So it will be I square. I square will be minus 1. What is I cube? I cube is I. That is I square into I. But I square is minus 1. So I cube is minus I. This is very important. What will be I raised to 4? I raised to 4 is basically square of I square. I square is minus 1. Minus 1 square is plus 1. Or you may also say, what is I raised to 4? See, observe the cursor. I raised to 4 is I cube into I. But I cube is minus I. So minus I into I is minus I square. But I square itself is minus 1. And that is why it is minus into minus. That is plus. Now, I will not generalize the result because many students do not understand that. But I will take few examples. Integral powers of I. Now, can I write I raised to 21? Basically, 21 is an odd number, right? So, it is I raised to 20 into I. Is this correct? Yes, it is. Now I raised to 20 is I square raised to 10, or you may say I raised to 4 raised to 5. That is also correct. But every even number need not be multiple of 4, but it is definitely multiple of 2. That is why. Now I square is minus 1. Minus 1 raised to 10 into I. Minus 1 has even index, so it is plus 1. So I is the answer. Is that clear? Now can you tell me what will be I raised to 147? Type your answer in chat box. What will be I raised to 147? 147 is an odd number, right? So I raised to 147 is what? I raised to 146 into I. 146 is not multiple of 4, but it is multiple of 2. So I square raised to 73. I square is minus 1. And what is minus 1 raised to 73? Minus 1. See, if index of minus 1 is even, answer is plus 1. If it is odd, answer is minus 1. So minus I. Last but not the least, division of complex numbers. Now in this case also, instead of considering a plus ib and c plus id, I will consider particular case so that it is understood easily. So let us consider z1 as 2 plus I and z2 as 3 minus 4i. And if we are asked to divide z1 by z2, is this division valid or allowed? Yes, because z2 is not equal to 0. It is not zero complex number. Okay. Now working rule is very simple. Please use brackets. Working rule is simple. To divide one complex number by other. To divide one complex number by other means to multiply both numerator and denominator by the complex conjugate of denominator. Denominator is 3 minus 4i. What is its complex conjugate? 3 plus 4i. Now many students ask, sir, why to multiply numerator also by that? Why not to multiply only denominator? I have written equal to sign. When I write equal to, I have to see that both sides are the same. If you just multiply denominator, number will change. So you have to multiply both numerator and denominator by complex conjugate, strictly complex conjugate of denominator only. Now you know how to multiply one complex number by other. So 2 into 3, 6 plus 8i plus 3i plus 4i square. In the denominator, don't waste time in writing 339 minus, sorry, plus 12i minus 12i. Every time this is going to happen because this is first plus second into first, I'm sorry, first minus second into first plus second. That is a minus b, a plus b, which is a square minus b square. 3 square is 9 minus, what is 4i square? 16i square. If you want, you can write 9 plus 12i minus 12i. So 12i minus 12i get cancelled. Minus 4i plus 4i. Product is minus 16i square. But I square is nothing but minus 1. So 6. 8i plus 3i, 11i. Now I square is minus 1. So I write minus 4 here. And here 9 minus 16 into minus 1. I directly write plus 16. Now numerator is 2 plus 11i upon 25. Every time you have to write complex number as what? A plus ib or a plus bi. So 2 upon 25 plus 11 upon 25i. Right? So you have to remember that to divide one complex number by other means to multiply both numerator and denominator by the complex conjugate of denominator. 。    。  。  。 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 . 。 。 . 。 。 . 。 。 . 。 . 。 。 . 。 。 . 。 . 。 . 。 . 。 . Now Tell me what is 1 upon 2 plus I. Simple one. How to divide complex number 1 by another complex number 2 plus I. Type your answer in chat box. Okay. Now to divide 1 by 2 plus I means to multiply numerator and denominator by complex conjugate of denominator. So 2 minus I upon 2 plus I into 2 minus I, 4 minus I square. I square is minus 1. So minus I square is plus 1. Denominator becomes 5. Please do not write 2 minus I upon 5. I think I am telling you this at least third to fourth time. You have to write answer in the form a plus bi or a plus ib. So 2 upon 5, split the numerator, plus minus 1 upon 5i. So real part is 2 by 5, imaginary part is minus 1 by 5. So that's it for today.